Good evening to all. Let's discuss another topic for heat exchanger, which is LMTD of heat exchanger. LMTD stands for Logarithmic Mean Temperature Difference, and this is very useful for calculation of or sizing of heat exchangers. So let's discuss about how to calculate LMTD for different configuration of heat exchanger. So LMTD, as said, is a logarithmic mean temperature difference, and this LMTD stands for overall temperature difference between the two fluids. So there must be some temperature difference between hot fluid and cold fluid, then only there will be heat transfer. So as said, it helps in sizing of heat exchanger, so it is important. So let's discuss how LMTD is calculated. LMTD formula you can use, how it is linked. So heat transfer is equal to U into A into LMTD. So LMTD is important. So LMTD is known, U is selected, and then you know the heat transfer, then area is calculated, and once area is calculated you can size for heat exchangers. Now the case number one, this is a parallel heat exchanger. So let's discuss. Let us assume actually there is no hard and fast rule, but I have considered. So hot fluid inlet is considered terminal 1 and hot fluid outlet is terminal 2. As said, this is just a reference. You can use another criteria or reverse way also. So you can say the case, this is terminal 1 because hot gas comes in at 120 degrees Celsius and goes out 45 degrees Celsius. This is terminal 2, and cooling water goes as a from terminal 1, you can say closer to this is 30 degrees Celsius and comes out is terminal 2 is 40 degrees Celsius. So let's calculate the LMTD for this case. If you look at the graph or surface versus x-axis and the temperature, this is hot fluid profile. T H1 120 degree comes to TS2 45. This is terminal 1 and terminal 2. At terminal 1, cooling water is TC1 30 degree and becomes TC2 40 degrees. So always there is separation or gap and difference, and that is why there is a heat transfer. So temperature difference at terminal 1, we call it as a TD1. So 120 divided by minus 30 degree, you can see is 90 degree Kelvin, because difference can be degree Celsius or Kelvin, both is the same. That is why I have written degree Kelvin, because adding 270 here and again minus this is same number. So temperature difference as terminal 2, this is 45 minus 40, which is 5 degree Kelvin. So maximum of these two terminals, that means TD1 and TD2, we call it as a GTTD, which is a greater terminal temperature difference, which is maximum of these two. So 90 degree, maximum is 90 degree. Similarly, minimum of TD1 and TD2, it is called LTTD, which is a lesser terminal temperature difference, which is a minimum of these two, which is 5. So now LMTD formula is GTTD minus LTTD divided by natural log, short it is written LM, GTTD divided by LTTD. So putting all the values, you can see LMTD is 29.4 degree Kelvin. What is cooler approach? This is cooler approach. 45 minus 40 degree is a cooler approach. But sometimes they always take process fluid or hot fluid outlet minus cooling water inlet. So in that case, cooler approach will be 45 minus 30 degree, which is 15 degree. But in actual case, you can see this is cooler approach, 45 minus 40 degree, which is 5. Now let's take off counter flow heat exchanger. So now it is a heat is a hot fluid is coming here. So we call terminal 1. So temperature TH1 is 120 degree, and it is comes out is terminal 2, which is 35 degree. Cooling water at terminal 2 is 30 degrees Celsius and comes out is 40 degree at terminal 1. So let's understand the graph on temperature on y-axis and surface is x-axis. At terminal 1, hot fluid is 120 degree and outlet, that is terminal 2, is 35. But at terminal 1 it is hot fluid because it is counter fluid. It is 40 degree because temperature movement is opposite, or flow of cooling water is opposite to the hot fluid. And at terminal 2 it is a TC1, that is 30 degree. So again we can calculate temperature difference at terminal 1 is 120 minus 40, because this difference you have to calculate, which is 80 degree Kelvin, and at terminal 2 is 35 minus 30 is 5 degree. So again maximum of these two, which is called GTTD, is 80 degree, minimum of these two is again pi. So LMTD is the same, you can use LMTD 80 minus 5 divided by natural log of 80 divided by 5, which is 27.1. Cooler approach is 35 minus 30, which is 5 degree for counter flow. Let's understand how to calculate LMTD for cross flow heat exchanger, like fin type heat exchanger, because in fin type heat exchanger you can see hot fluid comes here and crosses and aspirated all the way and then comes out this other side, which is perpendicular to the cooling water flow, and cooling water is flowing like 50% from this side, and if it is second pass then another 50% coming this. So hot fluid is on the hot side of what is called gas, and the cooling water, cooling inlet will be outlet of hot fluid. So this is arrangement you can see. So same thing it is in hot fluid comes and again sprayed all the way, and all the fins it crosses comes here and then finally goes out, and cooling water you see on the terminal 2 side, and then it is double pass comes here and then goes here. So 50% of tubes have cooling water flow on this direction and remaining 50% on this. So cooling water inlet temperature TC1 is 30 degree, outlet is 40 degree, hot fluid temperature TC1 120 degree, and outlet is hot fluid is 36 degrees Celsius. Cooling water pass two numbers, hot fluid pass one. Is two pass. From here to here is one pass, here to another pass. So cooling water two pass and hot fluid one pass. Temperature rise in each pass. We can divide. Difference of cooling water temperature divided by 2 pass, so 5 degree. That means from one pass temperature rise will be 5 degree. So cooling water temperature at the end of first pass or start of second pass will be, we call TC3, which is TC1 plus 5, which is 35. So 30, so here temperature becomes 35 and then 40 degree. So cooling water average temperature at terminal 2, I mean this cooling water, here is 30, here is 35, so you have to take the average. So average will be 32.5. Similarly, cooling water average temperature is terminal 1, which is 40 degree and 35. Take the average 35 plus 40, which is 37.5. So in fact, at terminal 1, average temperature is 32. Sorry, terminal 2 is 32.5 and terminal 1 is 37.5. So let's draw the curve on x-axis surface and y is temperature. Then you can see this is hot fluid 120 to 36 degree, and cooling water average temperature TC average 32.5 to 37.5. So again temperature difference as terminal TD1 is 120 minus 37.5, which is 82.5, and at temperature terminal 2 this 36 minus 32.5 is 3.5. So again you have to calculate maximum, which is called GTTD, which is 82.5. Minimum you have to calculate 3.5. Then LMTD you have to use the formula 82 minus 3.5 divided by natural log of 82.5 divided by 3.5, which is 25. So now what is a cooler approach? In fact, this is cooler approach. 36 divided by 32.5, which is 3.5. But as I said, in industry normally it is calculated 36 minus inlet of cooling water, which is 6 degree. Now the cell and tube heat exchanger for LMTD. So again you can see there is a parallel and counter flow arrangement in cell and tube, because 50% cooling water flows in this direction, we can call parallel side, and then 50% in counter flow side. And cooling water is two pass, and hot fluid is a single pass. So cooling water inlet temperature 30 degree Celsius, cooling water outlet temperature is 45 degree, hot fluid inlet temperature 80 degree, hot fluid outlet temperature 42 degree, cooling water pass CW pass 2 and hot fluid pass 1. So now you have to calculate temperature rise for cooling water. So you have to temperature rise in each pass will be 45 minus 30 divided by 2, because 2 pass, so 7.5. So cooling water temperature at the end of first pass, this section or start of second pass, will be 30 plus 7.5 is 37.5 degree Celsius. So cooling water, average temperature at terminal 1. So 30 degree, you can see terminal 1, 30 degree plus 45 degree divided by 2, which is 37.5, and terminal 2 will be the same, because TC3, which is 37. So both terminal you have the same temperature. So you can look at temperature profile from this to pass 1, temperature rises like this, then again rises like this. So at terminal 1, if you take the average, it is again coming as 37.5. This is why at terminal 1 and terminal 2 both temperature for cooling water is same, which is 37.5. Now again you have to see the profile, temperature profile for cooling water, and this is hot gas profile. So again you have to calculate. This is straight line, because both terminals are same temperature difference for cooling water. So temperature difference at terminal 1, we can calculate TD1, this temperature difference. Terminal 2 is 80 degree minus, terminal 1 is 80 degree minus 37.5, which is 42.5, and this is 42 minus 30.5, which is 4.5. So maximum of these two, which is GTTD, which is 42.5, and minimum of this LTTD is 4.5. So use this same formula for LMTD, which is coming as 16.9 degree Kelvin. So cooler approach at this is in fact 42 minus 37.5 is 4.5, but as I said, in industry normally it is used 42 degree minus cooling water inlet temperature, which is 30 degree, which is 12 degree. So I hope you have understood, and you have also enjoyed this session for how the LMTD of heat exchanger is calculated for different configuration. So thank you for watching, and see you in the next video.